Ever wondered why a coffee cup doesn't slide until you nudge it, and then keep sliding until something stops it? That's Newton's world. I'll hook you with a quick test. I'll explain the 3 laws clearly. I'll show how they apply to real life. Grab a sheet of paper and a coin, put the coin on top of the paper, yank the paper sideways fast. The coin drops almost straight down. Why? Inertia. You just met Newton's first law. Newton's first law. An object at rest stays at rest, and an object in motion stays in motion at constant velocity, unless acted on by a net external force. Translation. Things don't start moving, stop, or turn without a push or pull. That coffee cup? Friction with the table keeps it put. On ice, with less friction, it glides. Seatbelts? When the car stops, your body wants to keep going. The belt provides the force that changes your motion. The belt provides the force that changes your motion. Newton's second law connects force, mass, and acceleration. F equals m times a. Push the same force on a grocery cart and on a car. The cart accelerates. The car barely budges. More mass means less acceleration for the same force. Double the force on the cart? You double its acceleration if the mass doesn't change. Force in newtons, mass in kilograms, acceleration in meters per second squared. Net force is the sum of all pushes and pulls. If forces balance, acceleration is 0, even if you're already moving. That's why cruise control feels smooth. Newton's third law. For every action, there's an equal and opposite reaction. You push the ground backward, the ground pushes you forward. That's walking. Rockets expel hot gas down. The rocket is pushed up with equal force. No air needed, just mass ejected in the opposite direction. Punch a wall harder, it punches back equally. Your hand feels it. Starting a skateboard, you kick back on the ground, third law. Friction grips your shoe, first law keeps you rolling until friction and air slow you. Your acceleration depends on your push and mass, second law. Sports, a heavier basketball player needs more force to change speed than a lighter one. Equal and opposite forces show up in rebounds and tackles. Studying, isolate variables. If acceleration changes, ask, did force change, mass change, or both? Draw free body diagrams. Arrows for forces, longer arrow means bigger force. Why does a heavy truck take longer to stop? Greater mass needs more force or more time to reduce velocity. Why do astronauts float? They're in continuous free fall around Earth. First law in orbit, with gravity providing the centripetal force. Remember, inertia resists changes, force sets acceleration, and every push has a partner push. See these 3, and the world gets clearer, one nudge at a time.